We face an existential threat. Life as we know it is on the line. We have 12 short years to change everything, or it's game over. This is the terrifying scenario that's used by many leading politicians to justify a Green New Deal, an unprecedented increase in government power focused on the energy industry. The core idea of a Green New Deal is that government should rapidly prohibit the use of fossil fuel energy and impose 100% renewable energy, mostly solar and wind. This may sound appealing, but consider what it would entail. Today, 80% of the energy Americans use to heat their homes, farm their land, run their factories, and drive their cars comes from fossil fuels: coal, oil, and natural gas. Only 3.4% comes from solar and wind, despite decades of government subsidies and mandates to encourage their use. The reason we don't use much sunlight and wind as energy is that they are unreliable fuels that only work when the sun shines and the wind blows. That's why no town, city, or country has ever come close to 100% or even 50% solar and wind. And yet, Green New Deal proponents say they can do the impossible, if only we give the government control of the energy industry and control of major users of energy, such as the transportation industry, manufacturing, and agriculture. All of this is justified by the need to do something about the existential threat of rising CO2 levels. We're told on a daily basis that prestigious organizations like the United Nations have predicted mass destruction and death if we don't get off fossil fuels. What we're not told is that such predictions have a decades-long track record of getting it wrong. And by wrong, I mean completely missing the dartboard wrong. For example, in 1989, the Associated Press reported a United Nations prediction that entire nations could be wiped off the face of the Earth by rising sea levels if the global warming trend is not reversed by the year 2000. We're now 2 decades past 2000. We're not missing any nations, and human beings are living longer, healthier, and wealthier lives than ever before. But aren't things bound to get worse? Haven't scientists established that CO2 is a greenhouse gas with a warming influence on the planet? Yes, but that's only a small part of the big picture. Although CO2 causes some warming, it's much less significant than we've been told. Since we started using significant amounts of fossil fuels in the middle of the 19th century, we've increased the percentage of CO2 in the atmosphere from 0.03% to 0.04%, which correlates with an average temperature increase of about 2 degrees Fahrenheit. It also correlates with significant global greening, because CO2 is plant food. All of this is far from unprecedented territory for our planet, which has existed with at least 10 times today's CO2 levels and a 25-degree warmer average temperature. What is truly unprecedented, though, is how safe we are from climate. The International Disaster Database, a nonpartisan organization that tracks deaths from climate-related causes, such as extreme heat, floods, storms, and drought, shows that such deaths have been plummeting as CO2 emissions have been rising. How is this possible? Because of the fossil fuel energy that emitted the CO2, which has empowered us to climate-proof our environment with heating, air conditioning, sturdy buildings, mass irrigation, and weather warning systems. Fossil fuel energy has not taken a naturally safe climate and made it unnaturally dangerous. It's taken our naturally dangerous climate and made it unnaturally safe. Fossil fuels are not an existential threat. They're an existential resource because they increase something much more important than the level of CO2 in the atmosphere: the level of human empowerment. Increased life expectancy, income, health, leisure time, and education are all tightly linked to increased access to fossil fuels. Does this mean that we shouldn't look for lower carbon energy alternatives? Of course not. But the alternatives should lead us toward more abundant, more reliable power, not less. The most promising form of alternative energy is not unreliable solar and wind, but reliable, carbon-free nuclear energy. Sweden gets 40% of its electricity from nuclear, France over 70%. While nuclear energy is smeared as unsafe, it has actually been demonstrated by study after study to be the safest form of energy ever created. And yet, Green New Deal proponents, who say that we have 12 years to save the planet from rising CO2 levels, vigorously oppose nuclear, in addition to all fossil fuel use. By opposing every affordable, abundant, reliable form of energy, the Green New Deal won't protect us from an existential threat. It is an existential threat. I'm Alexk'Epstein, author of The Moral Case for Fossil Fuels for Prager University. Are wind and solar power the answer to our energy needs? There's a lot of sun and a lot of wind. They're free, they're clean, no CO2 emissions. So what's the problem? Why do solar and wind combined provide less than 2% of the world's energy? To answer these questions, we need to understand what makes energy, or anything else for that matter, cheap and plentiful. For something to be cheap and plentiful, every part of the process to produce it, including every input that goes into it, must be cheap and plentiful. Yes, the sun is free. Yes, wind is free. But the process of turning sunlight and wind into usable energy on a mass scale is far from free. In fact, compared to the other sources of energy, fossil fuels, nuclear power, and hydroelectric power, solar and wind power are very expensive. The basic problem is that sunlight and wind as energy sources are both weak, the more technical term is dilute, and unreliable, the more technical term is intermittent. It takes a lot of resources to collect and concentrate them, and even more resources to make them available on demand. These are called the diluteness problem and the intermittency problem. The diluteness problem is that, unlike coal or oil, the sun and the wind don't deliver concentrated energy, which means you need a lot of additional materials to produce a unit of energy. For solar power, such materials can include highly purified silicon, phosphorus, boron, and a dozen other complex compounds like titanium dioxide. All these materials have to be mined, refined, and/or manufactured in order to make solar panels. Those industrial processes take a lot of energy. For wind, needed materials include high-performance compounds for turbine blades and the rare earth metal neodymium for lightweight specialty magnets, as well as the steel and concrete necessary to build structures, thousands of them as tall as skyscrapers. And as big a problem as diluteness is, it's nothing compared to the intermittency problem. This isn't exactly a newsflash, but the sun doesn't shine all the time, and the wind doesn't blow all the time. The only way for solar and wind to be truly useful would be if we could store them, so that they would be available when we needed them. You can store oil in a tank. Where do you store solar or wind energy? No such mass storage system exists. Which is why, in the entire world, there is not one real or proposed independent, freestanding solar or wind power plant. All of them require backup. And guess what the go-to backup is? Fossil fuel. Here's what solar and wind electricity look like in Germany, which is the world's leader in renewables. The word erratic leaps to mind. Wind is constantly varying, sometimes disappearing completely. And solar produces little in the winter months when Germany most needs energy. Therefore, some reliable source of energy is needed to do the heavy lifting. In Germany's case, that energy is coal. So, while Germany has spent tens of billions of dollars to subsidize solar panels and windmills, fossil fuel use in that nation has not decreased. It's increased, and less than 10% of their total energy is generated by solar and wind. Furthermore, switching back and forth between solar and wind and coal to maintain a steady flow of energy is costly. Utility bills for the average German have gone up so dramatically that energy poverty has become a popular term to describe those who cannot pay, or who can barely pay, their electricity bills. If those bills one day go down, the reason will not be more solar and wind energy, but lower oil and coal prices. There's no free lunch, and there's no free energy, and that very much includes the highly expensive energy from the sun and the wind. I'm Alexk'Epstein of the Center for Industrial Progress for Prager University. Every year on Earth Day, we're supposed to reflect on all the ways we've made the planet worse. But what if we try something different? What if we reflect on all the ways we've made the planet better? Try this thought experiment. Imagine that we transported someone from 300 years ago, at the very start of the Industrial Revolution, to today's world. What would he think about our environment? Without question, his reaction would be one of disbelief. Not that we had destroyed his pristine natural world, but that such a clean, healthy environment was possible. The air is so clean, our time traveler might say. Where I come from, we're breathing in smoke all day from the fire we need to burn in our furnaces and stoves. And the water. Everywhere I go, the water tastes so fresh, and it's all safe to drink. On my farm, we get our water from a brook we share with animals, and my kids are always getting sick. And then the weather. I mean, the weather isn't that much different, but you're so much safer in it. You can move a knob and make it cool when it's hot, and warm when it's cold. And what happened to all the disease? In my time, we had insects everywhere giving us disease. My neighbor's son died of malaria, and you don't seem to have any of that here. What's your secret? I'd tell him that the secret was energy, specifically energy derived from fossil fuels, oil, coal, and natural gas. These fuels power machines that allow us to transform our naturally hazardous environment into a far healthier environment. Most of the natural world is too hot or too cold, has too much rainfall or not enough. Then there's bacteria-filled water, disease-carrying insects, tornadoes, earthquakes, and tsunamis, to name just a few of nature's unpleasant features. As our time traveler noted, 300 years ago, human beings spent a lot of time breathing polluted air from indoor fires. As unhealthy as it was worth the warmth. But we've been able to conquer all these environmental hazards. We've drained swamps, reclaimed land, cleared forests, built roads, constructed glass and steel skyscrapers. We've irrigated deserts, developed fertilizers and pesticides, linked oceans, all of it in humanity's incredibly successful effort to create a safer, cleaner, more habitable world. And we did most of this using machines running on cheap, plentiful, reliable energy from fossil fuels. To be sure, using that energy has carried risks and created negative byproducts. But thanks to technology, we get better and better at minimizing and neutralizing those risks. Los Angeles was once smog city. Now, its air is cleaner than it's been in decades. London's Thames River was once clogged with sewage. Now, it's clean. So, if you want to live in an environment that is safe, healthy, and clean, highly industrialized countries are the place to be. Where previous generations faced the risk of disease from simply drinking water, which was often contaminated, we have clean water, thanks to man-made reservoirs, treatment plants, underground pipes, and indoor plumbing. Where previous generations walked streets contaminated by large quantities of human and animal waste, we can conveniently and safely dispose of it thanks to sewer systems and the waste management industry. Where previous generations faced large-scale death whenever there was a severe freeze or heat wave, we can live in a comfortable climate year-round, thanks to insulated homes and modern high-energy heating and air conditioning. And the list of such life-improving positives goes on. Thanks to industrial agriculture and transportation, we have grocery stores full of healthy food year-round. Thanks to modern transportation, we have unprecedented access to the rich cultural experiences and natural beauty that the world has to offer. Many of the benefits of today's environment are reflected in life expectancy and population statistics. The average person lives longer in better health than ever before. In sum, human beings have made the Earth a far, far better place to live for ourselves. Yet even though life is better than ever, we are racked with guilt over our industrial development. We hear endlessly that our footprint, meaning our impact on nature, is too big, and that we must go green by making a smaller one. We are made to feel bad for the impact that we have on land, on water, on plants, on animals. But mastering nature is precisely how human beings survive and flourish. It's time to stop thinking about how to save the planet from human beings and resume thinking about how to improve the planet for human beings. I'm Alexk'Epstein of the Center for Industrial Progress for Prager University. What if I told you that someone had developed an energy source that could help us solve our biggest environmental challenges, purify our water and air, make our cities and homes more sanitary, and keep us safe from potential catastrophic climate change? What if I also told you that this energy source was cheap, plentiful, and reliable? Well, there is such a source. You probably know it as fossil fuel. Oil, natural gas, coal. But wait, don't fossil fuels pollute our environment and make our climate unlivable? That, of course, is what we're told, and what our children are taught. But let's look at the data. Here's a graph you've probably never seen: the correlation between use of fossil fuels and access to clean water. More fossil fuel, more clean water. Am I saying the more that we have used fossil fuel, the cleaner our water has become? Yes, that's exactly what I'm saying. In the developed world, we take clean water for granted. We turn on a tap, and it's there. But getting it there takes a massive amount of energy. Think of the man-made reservoirs, the purification plants, the network of pipes. In the undeveloped world, it's a much different story. They lack the energy, so they lack clean water. More fossil fuel, more clean water. The same is true of sanitation. By the use of cheap, plentiful, and reliable energy from fossil fuels, we have made our environment cleaner. Take a look at this graph. More fossil fuel, better sanitation. Okay, what about air quality? Here's a graph of the air pollution trends in the United States over the last half-century, based on data from the Environmental Protection Agency. Note the dramatic downward trend in emissions, even though we use more fossil fuel than ever. How is this achieved? Above all, by using anti-pollution technology, powered by fossil fuel, oil, natural gas, and coal. But even without modern pollution control technology, fossil fuel makes our air cleaner. Indoor pollution, caused by burning a fire inside your house, cabin, hut, or tent to cook and keep warm, was a deadly global problem until the late 19th century, when cheap kerosene, a fossil fuel byproduct, became available in America and Europe. Indoor pollution is still a major issue in the developing world today. The best solution? Fossil fuel. And now we come to the biggest fossil fuel concern of all: global warming. On this very sensitive topic, we need to get our terms straight. There is a big difference between mild global warming and catastrophic global warming. We can all agree on that, right? The issue isn't, does burning fossil fuel have some warming impact? It does. The issue is the climate warming dangerously fast? In 1986, NASA climate scientist James Hansen, one of the world's most prominent critics of the use of fossil fuels, predicted that if current trends are unchanged, temperatures would rise 2 to 4 degrees in the first decade of the 2000s. But as you can see from this graph, since 2000, the trend line is essentially flat. Little or no warming in the last 15 years. That's probably why we hear much less talk about global warming and much more talk about climate change. Has this climate change made our world more dangerous? The key statistic here, one that is unfortunately almost never mentioned, is climate-related deaths. That is, how many people die each year from a climate-related cause, including droughts, floods, storms, and extreme temperatures. In the last 80 years, as CO2 emissions have rapidly escalated, the annual rate of climate-related deaths worldwide has rapidly declined by 98%. The reason is that the energy from fossil fuel has allowed the developed world to build a durable civilization, one highly resilient to extreme heat, extreme cold, floods, storms, and so on. The developing world, where natural disasters can still wreak terrible havoc, would like the chance to do the same. But to do that, they will need a lot more energy. The cheapest, fastest, and easiest way to get that energy is from fossil fuels. In sum, fossil fuels don't take a naturally safe environment and make it dangerous. They empower us to take a naturally dangerous environment and make it cleaner and safer. I'm Alexkcepstein of the Center for Industrial Progress for Prager University. "97% of climate scientists agree that climate change is real." How many times have you heard that statement? Probably hundreds. It may seem like a compelling and scientific argument against fossil fuels, but it's one of the most illogical, unscientific arguments you can make. To see how, let's use this form of argument for another controversial product, vaccines. An anti-vaccine person approaches you and says, 97% of doctors say that the side effects of vaccines are real. What would you say in response? You'd probably say, yeah, but the benefits far outweigh the side effects. By saying that 97% of doctors agree that vaccine side effects are real, without mentioning any of the benefits of vaccines, the anti-vaccine activist is trying to get you to look at the potential dangers of vaccines out of context. When fossil fuel opponents say 97% of climate scientists agree that climate change is real, they are doing the same. Yes, using fossil fuels for energy has a side effect, increasing the amount of CO2 in the atmosphere. Okay, but what about the upside? In the case of fossil fuel, that upside is enormous. The cheap, plentiful, and reliable energy that makes modern life possible, and at a scale no other energy source can match. So how significant is the side effect? This raises another problem with the statement, 97% of climate scientists agree that climate change is real. It tells us nothing about the meaning or magnitude of climate change, whether it's a mild, manageable warming or a runaway, catastrophic warming. This is an example of the fallacy of equivocation, using the same term in different, contradictory ways. If someone were to say 97% of doctors agree that vaccine side effects are real, what exact vaccine side effects do the doctors agree on? That a certain number of babies will get a rash? Or that large percentages will get full-blown autism? Precision is key, right? But fossil fuel opponents don't want you to know the precise magnitude of climate change, because if you did, you wouldn't be scared of climate change, you would be scared of losing the benefits of fossil fuels. For example, listen to how Secretary of State John Kerry manipulates the 97% of scientists line. 97% of climate scientists have confirmed that climate change is happening and that human activity is responsible, he said in a speech in Indonesia in 2014. Later, in the same speech, he claimed that scientists agree that the world as we know it will change, and it will change dramatically for the worse. 97% of climate scientists never said any such thing. So what did the 97% actually say? It turns out nothing remotely resembling catastrophic climate change. One of the main studies justifying 97% was done by John Cook, a climate communications fellow for the Global Change Institute in Australia. Here's his own summary of his survey. Cook et al. Found that over 97% of papers surveyed endorsed the view that the Earth is warming up, and human emissions of greenhouse gases are the main cause. Main cause means over 50%. But the vast majority of papers don't say that human beings are the main cause of recent warming. In fact, one analysis showed that less than 2% of papers actually said that. How did Cook get to 97% then? First, he added papers that explicitly said there was man-made warming, but didn't say how much. Then he added papers that didn't even say there was man-made warming, but he thought it was implied. A scientific researcher has a sacred obligation to accurately report his findings. Cook and researchers like him have failed us, as have the politicians and media figures who have blindly repeated the 97% claim to support their anti-fossil fuel goals. How can we protect ourselves against this kind of manipulation? Whenever someone tells you that scientists agree on something, ask two questions. What exactly do they agree on? And how did they prove it? I'm Alexkcepstein, author of The Moral Case for Fossil Fuels for Prager University.